Hello all, welcome to the channel. In the previous video we have seen what is inductive effect and the types, and in today's video let us see the phenomenon called resonance. Before going into the resonance effect, we need to know what is resonance. So let us see this phenomenon first. So the example that is in front of you is the benzene structure. Benzene is the best example to explain the resonance phenomenon. We have other molecules also which shows resonance, but here we are considering benzene. So what is the phenomenon called resonance? The phenomenon of resonance is nothing but the molecule, the given molecule like benzene, if it is not able to written in a single form, you cannot write it in one form to explain all its properties, but you write it in multiple forms. As you can see, there are 5 forms for benzene. Okay, so when a molecule can be written in 2 or more forms, such phenomenon is called resonance. So how can you write resonance structures? You need to keep the basic structure the same. It should have 6 carbons linked one after the other, and the carbon skeleton has to be the same, but only what differs is the distribution of electrons will vary from one structure to the other, and the charges vary on one atom to the other. Only the electron distribution and the charges will differ, but the carbon skeleton is going to remain the same. So in one structure, if it is C6H6, in other structure it cannot be C6H5 or something else. So this is wrong. So in resonance, we write a structure, a molecule in various forms where the distribution of electron and the charges will vary, but the carbon skeleton remains the same. This is the phenomenon called resonance. Now, what are all these structures called? The main 2 structures, these are the structures given by Kekule. They are called Kekule structure. They are the most stable forms of benzene, and the remaining 3 are called Deva structures. Deva structures are not so famous because they do not give clarity about all the properties of benzene, but the Kekule forms are the most stable forms. So here, these are all forms are considered to be the canonical forms or the resonance structures. The various structures that we write for a compound in resonance are called canonical forms or the resonance structures. The mixture of all these forms that we write is considered to be the resonance hybrid. What is it? It is the resonance hybrid. We write it this way. This circle inside the benzene ring indicates the distribution of pi electrons throughout all the 6 carbons. This is known as resonance hybrid. Resonance hybrid is the most stable form of the structure which follows all the characteristics. So when we say the resonance hybrid is more stable compared to the canonical forms, it's in terms of energy. So the energy of resonance hybrid is very less compared to that of the remaining canonical forms. This difference in energy is called resonance energy. What is resonance energy? The energy gap that we see between all the canonical forms and the resonance hybrid, that is this form. So this is having the least energy. We know that energy and stability are inversely proportional. So hence resonance hybrid has the least energy and most stable form. So among all the structures, the resonance hybrid that we see here follows all the properties of benzene or the bond parameters, like the carbon CC bond here is not completely single and it is not completely double. It is in between. It is like this. That means all the carbon atoms, they experience single bond sometimes and double bond sometimes because of the delocalization of the pi electrons. Hence the carbon-carbon double bond in the benzene experiences the bond length in between single bond and double bond, which is 1.39 angstroms. For single bond it is 1.54 angstroms, For double bond it is 1.20 angstroms, but for benzene it is in between, less than single bond, greater than double bond, that is 1.39 angstroms. And the resonance energy or the energy gap that we experience between the resonance hybrid and the canonical forms is 36 kilocalories of energy. Now because of this resonance energy, benzene hybrid is more stable, and it helps in its reactivity also, like it undergoes reactions in electrophilic substitution reactions. Benzene, because of this extra resonance energy that it possesses, it participates in the electrophilic substitution reactions. This is the phenomena of resonance with the help of benzene molecule. Thank you. If you find the video helpful, please like, share and subscribe.